A kaleidoscope of colored light once defined medieval sacred spaces. Those magnificent stained glass windows were far more than decoration. They were complex mathematical expressions crafted in glass and lead. For centuries, their geometric secrets remained hidden in plain sight. By the end of our journey, you will be able to look at any medieval window and see the sophisticated code of shapes and proportions woven into its design. How did artisans without modern tools embed such precise geometry into their work? What cosmic truths were they trying to represent through these luminous patterns? What hidden order do you notice in the world's most beautiful designs? Numbers themselves were seen as sacred, a direct language of the Creator. The universe was not a random collection of objects, but a meticulously crafted design built upon perfect ratios and harmonious shapes. To study geometry was, in a very real sense, to study the mind of God. This was not a dry academic exercise. It was a spiritual quest for truth. So when a master glazier approached a sheet of colored glass with a cutting iron, they were not merely following a decorative pattern. They were participating in a divine act of creation, reassembling fragments of the material world into a higher spiritual order. Their workshop was a place of both physical craft and profound philosophical inquiry. Every circle they cut symbolized eternity, with no beginning and no end. Every triangle could represent the Holy Trinity, a concept given physical form through proportion and line. This deep, symbolic meaning is what elevated their craft from simple construction to a form of visual theology. The light streaming through the finished window was not just sunlight. It was divine illumination filtered through a mathematical and spiritual filter designed by human hands. This world, you provided the ultimate motivation for the intense precision we see in these windows. Why spend countless hours ensuring the curves of a stone tracery were perfectly executed? Why painstakingly arrange hundreds of glass pieces into a complex star pattern? Because a flaw in the geometry was more than a simple mistake. It was a misrepresentation of cosmic perfection, a failure to accurately reflect the divine blueprint. The beauty of the window was a direct result of its mathematical truth. This sacred geometry provided the essential bridge between the earthly realm and the heavenly, making the window itself a portal to a higher understanding. A circle holds a special kind of magic, a shape of infinite symmetry. To the medieval mind, this simple form was a direct echo of the divine, a perfect and unbroken line reflecting the unity of creation. The square offered a symbol of stability and the earthly realm, while the triangle pointed heavenward, a clear representation of spiritual ascent. These were not just convenient shapes for design. They were the fundamental letters of a universal language, a sacred geometry believed to be woven into the fabric of existence. This profound world, you provided the very blueprint for the stained glass master. Guiding their cutting iron was more than a sketch. It was a commitment to these divine proportions. One ratio appears with stunning frequency, a relationship known as the golden section. Imagine a line divided so that the smaller part relates to the larger, just as the larger part relates to the whole. This self-repeating proportion, often visualized in a graceful spiral, seems to hold an innate sense of balance. Artisans would subtly embed this ratio into the overarching layout of a window, determining the height against the width, or the placement of a central rose within the stone framework. Why would they go to such lengths? They held a conviction that these specific mathematical relationships produced a visual harmony that resonated deeply with the human spirit. A space built with these proportions did not just look orderly, it felt peaceful, balanced, and strangely uplifting. This was the true purpose of the mathematics. The precise arrangement of shapes and lines created a silent, visual rhythm that guided a person's gaze and, in turn, their state of mind. The mathematics was never a cold calculation. It was a warm, intentional current running beneath the surface of breathtaking beauty, designed to elevate the spiritual experience of everyone who stepped into the light of these windows. The rose window transforms a solid wall into a wheel of light, its symmetry so perfect it feels almost alive. Every element, from the delicate stone tracery to the brilliant glass panels, radiates outward from a central point in a perfect demonstration of rotational symmetry. To stand before the great roses of Chartres or Notre Dame is to witness a masterclass in circular geometry made luminous. Creating such a design required an intuitive grasp of mathematics far beyond simple measurement. The master builder's primary tool for this task was not a complex equation but a humble pair of compasses. With this simple instrument, they could step off perfectly equal segments around a circle's circumference, dividing the whole into mathematically precise portions. This foundational act of division was everything. A circle might be split into 12 identical segments, a number echoing the 12 apostles and creating a rich symbolic framework for storytelling. Alternatively, an 8-part division might be chosen, a number long associated with rebirth and resurrection. Once this underlying skeleton of the circle was established, the real artistry began. The compass was used again and again to inscribe smaller arcs and circles within the larger form, generating the intricate, lace-like patterns of stone that we call tracery. These curving lines intersect and weave, forming a stable geometric mesh that could support the immense weight of the glass while creating a sense of effortless, flowing beauty. The sheer sophistication of this process is what still captivates mathematicians today. How did these artisans, working centuries before formal calculus, visualize and then execute such complex interlocking patterns? They were not just craftsmen, they were geometers of light, using compass and rule to translate divine symmetry into a language of stone and colored glass that anyone could understand with their heart. The stone skeleton of a Gothic cathedral itself was a mathematical diagram brought to life. To create the iconic pointed arch, builders did not simply sketch a graceful curve. They turned to their most trusted tool, the compass, and drew 2 circles of identical size, allowing their edges to intersect. The upper arc of each circle was then connected, forming the distinct, soaring shape we recognize instantly. This was not merely an aesthetic choice. That intersecting geometry transformed the downward force of the heavy stonework, channeling it more efficiently into the supporting columns and walls. The result was a structure of breathtaking height and stability, made possible by the precise application of a simple geometric principle. These arches defined the tall, narrow openings that would become the canvases for the glazier's art. The window frame and the luminous image it held were conceived as a single, unified system. The architect provided the geometric bones with the stone tracery, dividing the vast opening into manageable panels. The glazier then filled these panels with their own intricate patterns of colored glass, a second layer of sacred geometry laid over the first. This seamless integration reveals a profound truth about these medieval projects. There was no separation between the engineer and the artist, between the practical and the beautiful. The mathematics that ensured the arch would stand was the very same mathematics that arranged the figures of saints and prophets into a harmonious composition. A single, coherent vision of cosmic order dictated the curve of a stone and the cut of a piece of blue glass. The building itself was a testament to the belief that truth, stability, and beauty all sprang from the same divine source code. How does this change the way you see these monumental structures? They are not just buildings, they are three-dimensional arguments built in stone and light, proclaiming that the universe is founded on a deep, intelligible, and beautiful order. This sacred geometry did not live only in the mind. It had to be translated into cut glass and lead within the busy confines of a workshop. The air would be thick with the smell of hot solder and wood smoke, a space where profound mathematical ideas met the gritty reality of craft. The Glazier's toolkit was remarkably simple, yet with it, they executed designs of breathtaking complexity. A pair of compasses, a straight edge, and a set of wooden templates were their primary instruments. These were not just tools for marking, they were the keys to unlocking a universe of perfect forms on a workbench littered with fragments of colored glass. The first and most critical step was to establish the master pattern, a full-scale drawing known as a cartoon. Using charcoal on a large whitewashed table, the master would lay out the entire design. The compass was indispensable here, stepping off equal divisions around a circle to create the petals of a floral motif or the points of a star. This act of division, of creating a dodecagon from a single circle, was a fundamental geometric operation performed with practiced ease. The straight edge ensured the long, clean lines of borders and architectural frames, while reusable wooden templates guaranteed that repeating shapes, like the leaves on a decorative vine, were perfectly consistent across a vast window surface. This was not guesswork, it was a disciplined, repeatable system. The true test of skill came when this two-dimensional pattern met the stubborn, brittle nature of glass. A glazier would place a piece of ruby or cobalt glass over a specific section of the cartoon. Then, with a hot iron, they would score the glass by following the lines of the drawing beneath, guided by the geometric truth they had established. A misaligned template or an imprecise compass opening would result in a flawed piece that would not fit its neighbor, breaking the sacred harmony of the whole composition. Their genius lay in this fusion of knowledge and hand. They understood that a circle divided into 6 equal parts creates a perfect hexagon, and that this hexagon could be the core of a radiating snowflake pattern. They knew how to use intersecting arcs to form the delicate trefoils and quatrefoils that filled the spandrels of a window. This was practical geometry in its purest form, a living knowledge passed from master to apprentice, ensuring that the cosmic order embedded in the design survived its translation into a fragile, luminous reality. The principles guiding the Glazier's hand did not appear from nowhere. Centuries before the first Gothic cathedral pierced the sky, the Roman architect Vitruvius laid down a revolutionary idea in his 10 books on architecture. He proposed that beautiful buildings should mirror the proportions of the human form, a perfect body with arms and legs outstretched fitting precisely within both a circle and a square. This classical concept of a microcosm, the human being as a miniature reflection of the cosmic order, never truly vanished. It was preserved, studied, and passionately adapted within the scriptoria of medieval monasteries, waiting for the right moment to be reborn in stone and light. When the great building campaigns began, these inherited ideas provided a ready-made language of harmony. The medieval master masons and glaziers were not slavishly copying the past. They were ingeniously translating this human-centered geometry into a new, distinctly sacred vocabulary. The circle that once contained the ideal man now framed the figure of Christ in a majestic rose window. The square that defined his earthly measure became the stable foundation for an entire lancet window's composition. This proportional system governed everything, from the grand sweep of a window's height and width down to the delicate arrangement of a saint's face and hands. Why does a figure in a 13th century window feel so balanced and serene, even to our modern eyes? It is often because its proportions are subconsciously familiar to us. They are our proportions. A head might be 1/8 of the total height of a figure, just as Vitruvius suggested. The distance from the chin to the forehead could define the module used to space out the lead lines in the canopy above. This created a profound visual coherence. A person viewing the window did not need to understand the underlying mathematics to feel its effect. They simply experienced a deep, intuitive sense of rightness, a harmony that resonated with their own humanity. This consistent application of proportion is what unites the disparate elements of a vast cathedral, built sometimes over hundreds of years by countless anonymous hands. The persistence of these mathematical principles across generations reveals something far deeper than a shared building technique. It speaks to a shared vision of the world, a unified belief that beauty, truth, and human dignity were all woven together by the same divine geometer. But the numbers themselves were not neutral. Every integer hummed with a spiritual significance, a secret meaning known to the artisans and scholars of the age. The geometry of the windows was a physical language, but the numbers were its sacred vocabulary, each one a key to a deeper theological truth. Take the number 3, the most fundamental of them all. It was the number of the Holy Trinity, the Father, Son, and Holy Spirit. This is why the trefoil, a shape composed of 3 overlapping circles, appears everywhere in the stone tracery and glass patterns. It was not a random decorative choice. It was a constant, silent affirmation of a core belief, a trio of forms locked in an eternal, harmonious dance. Then there is the number 4, the number of stability and the earthly realm. It called to mind the 4 evangelists who wrote the Gospels, the 4 cardinal directions, the 4 elements that composed the material world. A square or a quatrefoil pattern was a deliberate invocation of this sense of created order and completeness. And then we have the number 7, a number vibrating with the idea of divine perfection. It united the divine 3 with the earthly 4, symbolizing the 7 sacraments of the Church and the 7 gifts of the Holy Spirit. A window divided into 7 main lights, or featuring a complex 7-petaled floral motif, was embedding this concept of ultimate spiritual fulfillment directly into its design. These numerical values were not arbitrarily chosen for aesthetic appeal. They were part of a vast, coherent symbolic system where mathematics and theology were inseparable. A Glazier selecting a 12-part division for a circular window was not just making a geometric decision. He was invoking the 12 apostles, the 12 tribes of Israel, creating a framework rich with biblical resonance. This symbolic dimension transforms our understanding of the windows. What we might casually dismiss as a simple repeating motif is often a densely packed theological statement. The lead lines and glass pieces become the words and sentences of a silent sermon written in number and light. So the next time you see an image of a medieval window, pause and count. How many figures are in a row? How many petals does the central flower have? You are not just counting decorative elements. You are starting to decipher a hidden code, one that reveals how deeply the medieval world believed that God had written the universe in the language of mathematics. So how did a master glazier learn to think in this deeply mathematical way? The answer lies in an educational system that saw no boundary between art and science. The medieval university curriculum for advanced study was built upon the 7 liberal arts, divided into the trivium and the quadrivium. The trivium covered grammar, logic, and rhetoric, the arts of language and thought. But it was the quadrivium that provided the essential toolkit for the artisan. This was a 4-part mathematical education, comprising arithmetic, geometry, music, and astronomy. This was not a course of study reserved for cloistered scholars alone. Its principles permeated the workshops, providing the intellectual foundation for anyone who sought to create works of true harmony. Arithmetic taught the philosophy of number, the very essence of quantity. Geometry gave those numbers spatial form, the science of measurement and shape. Music revealed the hidden mathematics of sound and time, the ratios that made notes pleasing to the ear, and astronomy mapped these same principles onto the cosmos, studying the movements of the heavens. These four disciplines were not seen as separate subjects. They were understood as different expressions of a single, universal order. A master glazier trained in this world, you did not simply see a line on his cartoon. He understood it as a geometric expression of a numerical relationship that also governed a musical chord and the orbit of a planet. This is why the connection between musical ratios and visual beauty was so profound to them. They knew that the simple musical interval of an octave, the most consonant and pleasing sound, was produced by a string divided in a 1:2 ratio. A perfect fifth corresponded to a 2:3 ratio. These were not abstract concepts. They were the building blocks of cosmic harmony. The artisan sought to embed these same perfect ratios, these musical relationships, into the proportions of his window. The height of a lancet might relate to its width as 2:3, creating a visual equivalent of that perfect fifth. The arrangement of figures in a scene could follow the harmonic progression of a piece of sacred music. The lead lines themselves could trace a rhythm across the glass, a silent melody for the eyes. This interdisciplinary training created artists who thought in complete systems. A window was not a collection of isolated decorative elements. It was a single, unified composition, a visual chord structured by the same mathematical truths that made music beautiful and the heavens move in their perfect circles. The light passing through the glass was not just colored, it was, in a very real sense, tuned. Yet the geometric genius illuminating these cathedrals was not born in a vacuum. A profound intellectual debt was owed to Islamic scholars, whose sophisticated mathematical discoveries traveled north along bustling trade routes and through vibrant translation centers in places like Sicily and Spain. There, Christian, Jewish, and Muslim thinkers worked side by side, translating ancient Greek texts alongside groundbreaking Arabic commentaries, preserving and expanding a shared treasury of knowledge. This cross-cultural exchange left an indelible mark on the very patterns you see in the glass. The intricate star polygons and mesmerizing interlacing bands that grace the windows of later Gothic cathedrals, like the stunning Sainte-Chapelle in Paris, show a clear and direct lineage to the geometric traditions of the Islamic world. These were not random decorative borrowings. They were the result of European artisans encountering and mastering a new, more complex geometric vocabulary. Islamic artists had perfected the art of dividing the circle into intricate grids to generate infinite, non-repeating patterns, seeing this as a way to visually represent the infinite nature of the divine. European glaziers, already deeply immersed in their own sacred geometry, recognized a kindred mathematical spirit in these designs. They eagerly adopted these new forms, weaving 8-pointed stars and interlacing ribbons into their own stone tracery and glass narratives. This shared visual language reveals a stunning truth. The beauty of a mathematical pattern could transcend deep religious and political divides, becoming a universal currency of intellect and artistry. The same geometric principles that organized the tiles of a mosque in Cordoba could, within a generation, be directing the light in a chapel dedicated to a Christian saint. These windows, therefore, are far more than just Christian art. They stand as luminous monuments to a forgotten era of collaboration, testaments to the shared human hunger to uncover and express the fundamental order of the universe. A window's stone framework tells its own story of mathematical ambition. The earliest lancets were tall, slender slits in the wall, their geometry straightforward and their purpose purely functional. But the human mind, especially one steeped in sacred geometry, is never content with simple forms for long. The first great leap was plate tracery, where stone masons punched several circular openings through a solid slab of stone. This was geometry by subtraction, a simple yet powerful act of carving perfect shapes from a solid field. The next evolution, bar tracery, was a revolution. Instead of cutting holes in stone, the masons began to construct a delicate skeleton of thin stone bars, assembling the window's pattern like a geometric puzzle. This shift from carving to building opened a universe of new possibilities. Suddenly, the stone itself could trace the arcs of a compass, creating patterns of interlacing circles and trefoils that were both structurally sound and breathtakingly intricate. Each new pattern, from the rigid geometric grids of early Gothic to the flame-like curves of the later flamboyant style, was a direct result of masons solving a new structural equation. They were asking, how much stone can we remove and still hold the weight? How can we make this line flow more gracefully while maintaining its strength? Their answers were written in limestone and granite, each elegant curve a testament to a deeper understanding of load and counterforce. The lead cames that hold the glass are the final, crucial layer of this geometric web. A glazier did not simply join glass pieces at random. The leading pattern was a deliberate design choice, reinforcing the major lines of the composition and creating a secondary rhythm of dark lines against the colored light. Where two circles in the stone tracery met, the lead lines would often follow, creating a visual echo. In a complex canopy over a saint's head, the lead might trace a miniature arch, mirroring the grand architecture of the window frame itself. This meticulous alignment ensured that the entire window, from its stout stone ribs down to its slender lead seams, operated as a single, coherent mathematical expression. The evolution from a simple opening to a wall of undulating, flame-like stone is a clear record of a centuries-long conversation between ambition and geometry. It shows us a culture not content to rest on past formulas, but one that continually used its mathematical tools to reach for a new, more fluid kind of beauty, pushing stone and lead to their absolute expressive limits. The vibrant reds and deep blues of a medieval window do not clash by accident. Their harmonious relationship is a quiet triumph of mathematical color theory. A master glazier understood that color, like shape, had to obey the laws of proportion to achieve true visual music. With a palette often limited to a handful of intensely saturated hues, a ruby red, a cobalt blue, an emerald green, and flashes of gold or white, every placement was a critical calculation. They could not rely on a vast spectrum to create interest. Instead, they used number and ratio to distribute these powerful colors for maximum effect. A common approach was to treat the primary colors like notes in a chord. A large field of deep blue might be balanced by a precise amount of brilliant red, their relationship governed by a simple ratio like 1:2 or 2:3. This ensured that no single color overwhelmed the composition, creating a stable, luminous whole from a few potent ingredients. You can see this principle in action in the great narrative windows. The robes of saints and kings are not colored at random. The red of a martyr's cloak might appear at mathematically determined intervals across the window, creating a visual rhythm that guides the viewer's eye through the story. A sequence of blue backgrounds might gradually lighten in tone, following a proportional scale that creates a sense of depth and heavenly ascent. This meticulous distribution prevented the window from feeling like a chaotic mosaic of color. Instead, the limited palette became a strength. its repetition and variation creating a cohesive and powerfully resonant image. The mathematics of color ensured that the window's message was not lost in a blaze of pure sensation. The result is an artwork that feels both intensely vibrant and profoundly peaceful, a testament to the Glazier's belief that number brought order to every aspect of creation, even the wild beauty of light itself. These pattern books are the closest thing we have to a medieval software manual. Within their pages, you find no complex equations, but rather step-by-step sequences of geometric operations, a visual algorithm for generating beauty. A master glazier could begin with the simplest of forms, a single square or an equilateral triangle drawn on a parchment grid. The first operation might be a translation, sliding that shape repeatedly along a straight line to create a basic border. Then came rotation, pivoting that line of shapes around a central point to form a circle or a star. Finally, reflection could be employed, mirroring the entire arrangement across an axis to produce a perfectly symmetrical design. This systematic approach meant that an apprentice did not need to be a creative genius to produce work of stunning complexity. They simply needed to learn the process, to internalize the logic of the algorithm. By repeating these basic moves, they could generate an almost infinite variety of unique patterns, from the simple trefoils of early Gothic to the dizzying, flame-like networks of the later periods. This was the secret to the incredible consistency we see across windows crafted by different hands, sometimes in different countries. They were all running the same geometric program. The efficiency this brought to the workshop was immense. A master could design a single, elegant geometric sequence, and his team could replicate it perfectly across dozens of large windows, saving immense time and ensuring a cohesive visual identity for the entire cathedral. This methodical generation of forms speaks to a mindset that saw the universe itself as a set of logical, repeatable processes. The divine creator was the ultimate programmer, and the glazier, with compass and straightedge, was simply writing a small, local subroutine in the language of light and glass. Every lead line in a window served a dual purpose, acting as both a pen stroke in a drawing and a vital structural support. This was mathematics in its most practical form. A glazier could not simply draw a beautiful pattern and then fill it with glass. They had to engineer it for permanence, calculating the size and shape of each piece to ensure the entire assembly would withstand wind, weather, and its own considerable weight. A piece of glass cut too large would be dangerously fragile, prone to cracking from the slightest flex in the lead framework. One cut too small would create a weak point, a spot where the lead could buckle under stress. The solution was a geometric discipline imposed on the entire design. The dense network of lead cames, the H-shaped strips that hold the glass, was not random. It followed the primary lines of the underlying cartoon, reinforcing the major geometric shapes. Where two circles intersected in the stone tracery, the lead lines would often follow that same curve, creating a secondary web of support that echoed the stone. This created a kind of double reinforcement, a geometric truth in stone mirrored by a geometric truth in lead. The size of the glass pieces was determined by this structural grid. In areas of high stress, like the bottom of a tall lancet, the glazier would use a tighter, more frequent grid, resulting in many smaller, stronger pieces of glass. In the more stable upper sections, they could afford the luxury of slightly larger panels, allowing for more detailed painting and a grander visual sweep. This was a constant negotiation between the desire for breathtaking artistry and the uncompromising demands of physics. The lead itself became part of the composition, its dark lines tracing the essential geometry that held everything together. The result of this meticulous engineering is why so many of these windows have survived for 800 years or more. They are not fragile decorations. They are resilient, integrated systems where every diamond of red glass and every sliver of white is a carefully calculated component in a mathematical masterpiece. The beauty we see is therefore inseparable from the strength that preserves it, a perfect fusion of artistic vision and structural intelligence. One proportion appears with a frequency that is simply too perfect to be mere coincidence. Known today as the golden ratio, this specific relationship of approximately 1.618 to 1 was seen as the signature of divine harmony. You can find it quietly governing the grand layout of an entire stained glass window, where the height relates to the width in this exact proportion, creating a rectangle that feels inherently balanced and complete. Look closer and you will see it again in the way a central scene is framed within a window, the borders and internal divisions all obeying this silent rule of balance. Even the figures depicted in the glass, from a saint's serene face to the elegant drape of a robe, were often drawn using these same ideal proportions. The medieval artisans did not calculate this ratio using numbers or decimals. Theirs was a world of geometry of pure form. With nothing more than a compass and a straightedge, they could construct this golden section directly onto their full-scale cartoons. They would draw a square, extend a line from its midpoint to an opposite corner, and then use that length as a radius to swing an arc that would define the longer side of a perfect golden rectangle. This was knowledge held in the hand, a physical skill passed from master to apprentice. Why was this particular shape so revered? It was believed to possess a unique visual music, a harmony that resonated with the very structure of the human eye and spirit. A window built on these proportions did not just look beautiful, it felt right. It created a sense of serene order that prepared the mind for contemplation and prayer. The persistent, almost hidden use of the golden ratio across countless windows and cathedrals is perhaps the strongest evidence of the medieval world's deepest conviction. They were not just building structures or crafting art. They were assembling a visual universe according to what they believed were the creator's own favorite blueprints, making the sacred space a direct reflection of a cosmic and mathematical perfection. A sheet of medieval glass is never perfectly flat. Its subtle, organic variations in thickness were not flaws to be corrected, but a powerful design element to be mastered. The Glazier understood that a thicker section of ruby glass would transmit a deep, wine-colored shadow, while a thinner area of the same piece would blaze with a fiery, brilliant crimson. This was the final, breathtaking layer of their mathematical art, the calculated manipulation of light itself. They arranged their leading patterns with the precision of a composer writing a musical score, knowing that the dark lines would not only hold the glass but also cast specific shadows, adding depth and rhythm to the luminous field. The entire window was engineered as a dynamic filter for sunlight. In the soft, diffuse light of a cloudy morning, the colors would appear deep and saturated, like jewels in a quiet setting. As the sun climbed higher, its direct rays would ignite the thinner portions of the glass, making the window shimmer with an internal fire. The Glazier could even choreograph color mixing from a distance. By placing a small piece of yellow glass strategically over a larger blue one, the lead line would disappear from the viewer's perception, creating a seamless area of green light below, a visual alchemy guided by geometric placement. This was mathematics in service of emotion. The ultimate goal was to transform the physical space of the church into a vessel for spiritual feeling. The calculated interplay of thick and thin glass, of dark lead and brilliant color, generated a luminous atmosphere that felt both tranquil and exalted. The light itself became a theological statement, a visible manifestation of divine grace that shifted and changed with the hour, reminding all who were present that the sacred was not a static image, but a living, breathing presence in the world. A cathedral in France feels mathematically distinct from one in England or Germany, despite sharing the same core principles. This is because the universal language of sacred geometry was spoken with a rich array of local accents. French master glaziers, particularly those working on the great cathedrals of the Île-de-France region, displayed a breathtaking appetite for complexity. Their windows are symphonies of intricate geometric tracery, with circles subdivided into elegant star polygons and patterns of interlacing arcs that create a sense of limitless, luminous lace. This was geometry as dazzling intellectual display, a testament to the master's ability to command the most sophisticated forms. Travel to England and the mathematical emphasis shifts. English designers often favored a more vertical, linear progression, creating windows that soared with a kind of stately, rhythmic harmony. Their proportional systems frequently relied on repeating bays and a clear, sequential order that feels almost musical in its structure. It is less about dizzying complexity and more about a profound, grounded balance, a different kind of perfection found in measured, repeating intervals. Meanwhile, German workshops developed their own unmistakable style. Their approach to mathematical organization often resulted in windows with a powerful, almost monumental quality. The geometric grids are bold and assertive, the lead lines forming strong, dark networks that hold brilliantly saturated colors. The figures within these rigorous frames possess a solid, volumetric presence, showing a distinct approach to applying proportion to the human form. These regional fingerprints are not evidence of different mathematical truths, but rather of different cultural interpretations of the same eternal principles. A French rose window, an English lancet, and a German armorial panel all rely on the same sacred ratios and compass-based constructions. The local aesthetic preferences and technical traditions simply dictated which aspects of the geometric toolkit were emphasized and celebrated. This beautiful diversity proves something profound. The understanding of geometry was not a secret held by a few isolated geniuses. It was a deeply embedded, widespread literacy that allowed artisans from York to Cologne to Chartres to participate in a continent-wide conversation, each adding their own unique verse to a shared song of light and number. This geometric tradition was far from a rigid cage. A master glazier's workshop developed its own unique handwriting, a subtle but recognizable signature woven into the mathematical fabric of the windows. While every artisan worked within the same sacred language of circles and ratios, their individual approaches to solving geometric problems created distinct local dialects of design. You can see this in the specific way one workshop might choose to resolve the intersection of two arcs in a rose window's tracery. One master might favor a sharp, clean intersection, creating a pattern that feels crisp and precise. Another, just a generation later in the same city, might design the same basic shape so that the arcs flow into one another with a softer, more lyrical curve. These were not random aesthetic choices. They were creative decisions made within a strict mathematical framework, small innovations that revealed a deep and personal engagement with geometry. The underlying harmonic coherence never wavered. The window would still be perfectly proportioned and structurally sound, but the specific path taken to achieve that harmony bore the mark of an individual mind. This is why experts can sometimes identify the work of a specific, though often unnamed, master across different cathedrals. They recognize a consistent preference for a certain kind of star polygon, or a particular method of subdividing a square that acts like a geometric fingerprint. This beautiful tension between rule and innovation is what gives medieval stained glass its enduring vitality. It was not a mechanical art of copying. It was a living tradition where disciplined knowledge provided the foundation for genuine creative expression, allowing each master to leave their own quiet, luminous signature on the cosmos they sought to represent. These surviving manuscripts offer a rare glimpse into the mind of the medieval designer. Tucked away in libraries and archives, these pattern books are filled not with finished art, but with the skeletal frameworks of geometry. On pages of parchment, you find circles meticulously divided into 12 parts, squares inscribed with intricate lattices of lines, and sequences of arcs that blossom into complex floral patterns. Each diagram is a set of instructions, a visual algorithm for generating the tracery of a rose window or the leaded panels of a saint's robe. This was the crucial planning stage where the mathematical harmony of the final window was first established on a small, manageable scale. The draftsman would begin with foundational shapes, using a compass to step off perfect segments around a circle's circumference. From this primary division, secondary arcs could be swung, their intersections creating the points for smaller circles and the elegant curves of trefoils and quatrefoils. This step-by-step process demystifies the apparent complexity. What looks like an impossibly intricate lace of stone and glass often started with a few simple, repeatable geometric moves. The pattern book was the master key, a repository of proven formulas that could be adapted and recombined for any new commission. An apprentice learned by copying these diagrams, internalizing the logic of the compass until they could generate new variations without a second thought. The sheer precision of these drawings reveals the intellectual rigor behind the craft. This was not a vague sketch followed by intuitive adjustments. It was a precise blueprint, a mathematical contract that ensured the final window, crafted by many hands, would hold together as a single, harmonious whole. The beauty that floods the cathedral nave was born from the quiet, methodical order of lines on a page. Yet the brilliant mathematical light shining through these windows could not burn forever. A profound shift in artistic priorities began during the Renaissance, one that slowly dimmed the intricate geometric understanding of the medieval masters. The new obsession was with creating the illusion of depth on a flat surface, with linear perspective and realistic human forms. A stained glass window was no longer conceived as a sacred geometric diagram filtering divine light. It was increasingly treated as a transparent painting, a picture you could see through. Artists now sought to mimic the natural world, to tell stories with dramatic shadows and receding landscapes. This new aesthetic prized pictorial realism over the symbolic harmony of pure shape and number. The complex, interlocking patterns of the rose window gave way to large, clear panels of glass that served as mere backdrops for painted scenes. The lead lines, once an integral part of the geometric design, were now seen as obstacles to be minimized, unfortunate necessities that broke up the illusion of a continuous pictorial space. The deep knowledge of how to divide a circle into a perfect dodecagon, or how to generate a pattern through a series of rotational symmetries, began to fade from the glazier's workshop. It was not that the craft disappeared, but its spiritual and mathematical heart had changed. The language of sacred geometry was slowly forgotten, replaced by a new vocabulary of realism and humanism. For centuries, the sophisticated code embedded in the medieval windows remained unread, their mathematical brilliance obscured by the very clarity of the glass that replaced them. Then, in the 19th century, a remarkable rediscovery began. The Gothic revival was more than just a nostalgic style, it was a scholarly movement. Architects and artists like Augustus Pugin and Eugene Viollet-le-Duc passionately believed that the Middle Ages represented a lost golden age of art and spirituality. They did not simply copy the outward forms of Gothic cathedrals, they sought to understand the principles that made them work. They traveled across Europe with measuring tapes and sketchbooks, meticulously documenting the proportions of ancient windows, the curves of stone tracery, and the patterns of leaded glass. Through this painstaking analysis, they began to decipher the hidden mathematics. They realized that the seemingly random beauty of a window was anything but random. They uncovered the recurring ratios, the geometric constructions with compass and straightedge, the symbolic use of number. This was not merely an artistic revival, it was a genuine recovery of lost knowledge, an important chapter in the history of mathematics itself. The Gothic revivalists proved that the medieval glaziers were not just devout craftsmen, they were geometers of the highest order, whose work could only be fully appreciated once their mathematical language was spoken again. A digital camera now peers where the human eye cannot easily see. Researchers employ high-resolution imaging to capture every detail of a stained glass window, from the subtlest curve of a lead line to the precise hue of a 1,000-year-old piece of glass. These vast digital files become the raw data for a new kind of exploration. Complex algorithms designed to recognize patterns and measure proportions scan the images pixel by pixel. They are not looking for a story or a symbol, but for the silent, underlying grammar of the window's design. This computational analysis reveals geometric relationships that were once the sole province of the master glazier's intuition. The software might map the distribution of a specific color, revealing that the brilliant red glass is not scattered randomly but appears at points determined by the golden ratio. It can trace the primary axis of a composition, proving that the entire layout is generated from a single, repeated equilateral triangle, a shape rotated and reflected to create breathtaking complexity from a simple origin. These technological tools act as a kind of mathematical microscope, allowing us to see the precise skeletal structure upon which the beautiful skin of color and narrative was draped. The findings are consistently astonishing. Windows that appeared to the naked eye as a harmonious but perhaps intuitive arrangement are shown to be meticulously planned mathematical systems. A seeming imperfection in a curve is revealed to be a deliberate adjustment to maintain a proportional relationship across the entire surface. This is not cold data analysis. It is a conversation across 8 centuries, a confirmation that the artisans' understanding of geometry was both profound and consistently applied. The algorithms are simply learning to read a language that was almost lost, verifying that the hidden order you feel when standing before these windows is not just an emotion, but a measurable mathematical reality. What we experience as beauty, the computer reads as a flawless equation. That same geometric brilliance that lifted medieval spirits now illuminates modern classrooms. Teachers are discovering that these ancient windows provide a stunningly effective bridge to abstract mathematical concepts, transforming a subject many find intimidating into a tangible and beautiful exploration. A student struggling to visualize rotational symmetry on a flat worksheet can look at a rose window and instantly understand how a single shape, rotated around a central point, creates a perfect harmonious whole. The lead lines tracing a star polygon become a clear, physical example of geometric construction, while the repeating figures in a narrative lancet offer a direct illustration of translation along an axis. This is not just math history, it is a living application that connects art, culture, and science in a single, captivating image. Educators use high-resolution photographs of windows from Chartres or Canterbury to lead students through hands-on activities, challenging them to identify the different symmetry groups present or to reconstruct the underlying geometric grid using only a compass and a straightedge, just as a medieval apprentice would have done. This approach makes the mathematics feel less like a set of arbitrary rules and more like a universal language for creating beauty, a language that was spoken fluently centuries ago. The windows demonstrate that proportional thinking is not confined to textbooks. It is the very foundation of what we perceive as balanced and pleasing to the eye. By analyzing the layout of a window, students engage in real-world problem-solving, calculating ratios, and exploring how the relationship between numbers translates directly into visual harmony. This educational repurposing proves the timeless power of these artworks. They were built to communicate spiritual truths, but they continue to teach, now serving as luminous portals that make complex ideas accessible across the centuries. How might your own understanding of math change if you had learned it not from a textbook, but through the colored light of a cathedral window? This mathematical language of light is far from a lost artifact. A quiet revolution is unfolding in studios where glass is cut and lead is soldered today, as contemporary artists consciously reach back through the centuries to reclaim these geometric principles. They are not creating historical replicas, but engaging in a profound dialogue with the medieval masters, applying ancient ratios and patterns to express thoroughly modern sensibilities. An artist might study the precise geometric breakdown of a 13th-century rose window, not to copy its floral motifs, but to understand the underlying logic of its rotational symmetry. They then apply that same structural logic to an abstract composition, where the interlocking shapes speak of cosmic connections or digital networks rather than biblical parables. The sacred golden ratio, once used to frame the figure of a saint, might now govern the dynamic balance of an entirely non-representational panel, proving that the harmony it creates is independent of any specific narrative. This is more than mere inspiration, it is a direct transmission of knowledge. These modern glaziers have discovered that the medieval toolkit of compass and straightedge offers a unique path to creating work that feels both intellectually rigorous and deeply resonant. A window designed with these timeless proportions possesses a certain inevitability, a rightness that our eyes recognize even when our minds cannot name the reason. This artistic revival demonstrates a stunning truth. The most powerful design principles are not bound by the era of their origin. They are universal tools for creating beauty and meaning, waiting to be picked up by any hand that understands their power. The conversation between number and light, begun 1,000 years ago, is still very much alive, and the windows being created today are its newest, vibrant sentences. A cathedral was never intended as a collection of separate beautiful objects. It was conceived as a single, unified mathematical instrument, and the stained glass windows were its most vital components. Every element in the sacred space, from the vast sweep of the vaulted ceiling down to the carved leaves on a capital, was bound together by a shared set of proportional rules. The architect began with a single geometric unit, perhaps the width of the nave, and used it to generate all other dimensions. The height of the arches, the spacing of the columns, and even the size of the windows were all determined by multiplying or dividing that original measurement by sacred ratios. This created an invisible web of numerical relationships that tied the entire structure together into a coherent whole. The stained glass was not an afterthought inserted into a finished stone shell. It was the luminous culmination of this system. The geometric patterns in the glass directly echoed the rhythms established in the architecture. The great rose window high on the west front might precisely mirror the proportions of the circular labyrinth inlaid in the floor far below, one in light and the other in stone. The vertical divisions of a lancet window would often align perfectly with the bays of the arcade, creating a visual harmony that guided the eye upward. This integration went even deeper. the figures depicted in the glass were scaled according to the same proportional system, their size and placement determined by the mathematical order of the window frame itself. A prophet in a central panel was not just a random figure, he was a measured element in a vast compositional equation. This holistic vision transformed the entire building into a total work of art, a microcosm built according to the same divine mathematics believed to govern the cosmos. To step inside was to enter a tuned space where the silent music of architecture and the colored light of the windows sang the same harmonious chord. The windows were the final, essential layer that made this cosmic order visible and emotionally resonant, bathing the entire mathematical scheme in a transformative, heavenly glow. A shattered piece of medieval glass holds more than just a broken image. It contains a fragment of a mathematical code, and today's conservators are the cryptographers. When a window damaged by time or conflict arrives in a modern laboratory, the first step is not simply to replace the missing panes. It is to perform a deep geometric analysis, mapping every surviving piece to uncover the original proportional system. They begin by meticulously photographing the entire panel, then feeding this data into software that can trace the underlying grid. The algorithm searches for the ghost of the master glazier's compass, identifying the primary circles and the axes from which the entire design was generated. This digital autopsy reveals the silent logic that organized the beauty. A conservator might discover that the seemingly random floral border is actually generated by a series of perfectly rotated equilateral triangles, or that the lead lines follow the precise intersections of a golden rectangle. This recovered blueprint becomes the essential guide for any repair. If a section of blue glass is missing from the robe of a saint, the restorer does not cut a replacement to fit the hole. They cut it to fit the rediscovered geometric module, ensuring the new piece reinforces the original harmonic structure rather than disrupting it. This mathematical fidelity is what separates true conservation from simple patching. It ensures that the window does not just look whole again, but that it continues to function as the sophisticated mathematical instrument it was always meant to be. The dialogue between ancient and modern is a continuous loop. A 21st century laser cutter, guided by software, can now fabricate a piece of glass that perfectly matches a curve first drawn with a charcoal stick on a whitewashed table 800 years ago. The tools have changed, but the reverence for the original geometry remains the same, a testament to the enduring power of number to preserve beauty across the centuries. This geometric language of light and form was not confined to the Gothic cathedral. The same deep principles of mathematical order can be found illuminating sacred spaces across the world's great traditions, each expressing a unique vision through a shared grammar of shape and ratio. Consider the intricate rose windows that adorn medieval synagogues in places like Prague. Here, the six-pointed Star of David is not merely a symbol. It is a complex geometric generator created by the elegant interplay of two overlapping equilateral triangles. This hexagram provided a framework for glaziers to fill with intricate, smaller patterns, creating a luminous expression of faith built upon a foundation of perfect triangles, a design both symbolically rich and mathematically profound. In the Islamic world, the artistic approach to geometry reached breathtaking levels of abstraction. While stained glass as known in Europe was less common, the same principles manifested in the magnificent stained glass windows of mosque lamp holders and the pierced stone screens known as mashrabiyah. Islamic artisans perfected the art of infinite pattern, using compass and straightedge to create interlocking star polygons and flowing arabesques that visually represented the boundless nature of the divine. A single, complex star could be repeated and reflected across a vast surface, creating a sense of eternal, repeating order without beginning or end. This was a different theological statement from the Christian narrative windows, yet it was achieved using the very same geometric tools: the division of the circle, the rotation of a fundamental shape, the harmony of intersecting arcs. Even in secular contexts, this mathematical impulse flourished. The great hall windows of medieval guild halls and town halls often displayed elaborate armorial designs, their shields and heraldic beasts arranged within strict geometric grids. The beauty of these windows was meant to convey civic order, stability, and pride, virtues expressed through the clarity and balance of their mathematical composition. What does this global perspective reveal? It suggests that the drive to encode mathematics into art is a universal human trait. Different cultures with vastly different beliefs all arrived at the same conclusion: that certain shapes and ratios possess an innate power to create harmony that resonates with the human spirit. The specific symbols, a cross, a star, a floral arabesque, carried distinct meanings, but the underlying geometry was a common tongue. This was not a case of one culture borrowing from another, but of many minds independently discovering the same fundamental truths about beauty and order, and then using those truths to build their own unique bridges to the divine or to the ideal community. The light that passed through these varied windows was filtered through different cultural lenses, but it was always tuned by the same timeless mathematics. These luminous masterpieces offer us a final, profound lesson from the medieval mind. We have walked through a world where number was a form of prayer, where geometry was the syntax of the sacred, and where a glazier's compass was a tool for translating cosmic order into colored light. The vibrant windows are far more than static images from a distant past. They are living arguments for a universe built on intelligible, beautiful principles, a harmony we can both see and feel. That deep, intuitive sense of rightness you experience standing before them is not an accident. It is the direct result of 8 centuries of mathematical thinking, a silent music composed in lead and glass. So the next time you pass a church, a chapel, or even a modern building with stained glass, pause for a moment. Look past the familiar stories and brilliant colors. See the circles within circles, the balancing ratios, the intricate symmetry. You are witnessing a conversation between human hands and divine proportion, a legacy of wonder that asks us to find pattern and meaning in our own world. What geometric wonders have you noticed in the architecture around you? Share the hidden mathematical mysteries you discover in the